Gravity, it's the force that keeps us grounded and the planets in orbit. But what if it's not a fundamental force, but an emergent phenomenon of something more basic? In the 19th century, Lord Kelvin proposed a revolutionary idea: atoms as tiny vortexes. This suggested that complex particle behaviors could be explained by simple swirling motion. Around the same time, James Clerk Maxwell was developing his famous equations. These equations, which describe how electric and magnetic fields interact, bear a striking resemblance to the equations of fluid dynamics. Inspired by Maxwell's work, Albert Einstein applied these ideas to the motion of celestial bodies. This led to his theory of general relativity, which describes gravity not as a force, but as the curvature of space-time caused by mass and energy. But what if space-time itself could be described as a kind of fluid? This is the idea behind the theory of quantum vacuum, a theory that extends Maxwell's electromagnetic theory into the realm of quantum mechanics. In this theory, the equations for vortices in a fluid are identical to the equations for the Schwarzschild metric, which describes the space-time around a black hole. In the cosmic dance, virtual mass emerges, akin to whirlpools in water, suggesting an explanation for the mysterious, dark matter halos around galaxies. This virtual mass reflects the structure of the Riemann sphere, a mathematical concept that unifies complex numbers. The behavior of this virtual mass undergoes transformations similar to those in fluid dynamics and relativity, known as Prandtl-Glauert and Lorentz transformations respectively. This suggests a deep connection between fluid dynamics, the nature of space-time, and the structure of the universe. In essence, the vacuum of space isn't empty but filled with energy, intertwining quantum vacuum dynamics, topological transformations, and relativistic physics. This paints a new picture of our universe, where the elusive dark matter could be understood as virtual mass arising from the universe's own dynamics. This suggests a deep connection between the physics of vortices and the physics of gravity. The flat spacetime of Minkowski corresponds to disordered vortex axes, while the curved spacetime of Schwarzschild corresponds to ordered vortex axes. But perhaps, the most exciting implication of this theory is that gravity itself could be an emergent phenomenon of the Larmor frequency precession of the magnetic field. Just as heat can emerge from the random motions of particles, gravity could emerge from the collective behavior of these quantum vortices, analogous to the Lorentzian light cones in relativity. This brings us to the concept of gravitational heat. In the same way that friction between particles generates heat, the interaction between these quantum vortices could generate a form of heat, a gravitational heat. This heat could be the source of the mysterious dark energy that is causing the universe to expand at an accelerating rate. The difference between the flat spacetime of Minkowski and the curved spacetime of Schwarzschild could then be understood as a difference in gravitational temperature. This temperature difference could be the key to understanding the structure and dynamics of the universe. This theory, known as the general theory of singularity, has far-reaching implications. It suggests that phenomena like terrestrial gamma-ray flashes could be manifestations of dark energy. These flashes may be explained by quantum molecular hydrodynamics in the vacuum, resulting from the cavitation of quantum gravity or Planck masses that constitute dark matter in space. Like Einstein's equations link mass and spacetime curvature, Bernoulli's equation connects fluid speed and pressure. This suggests a profound connection between gravity and hydrodynamics, bridging the cosmos and the quantum world. In the grand tapestry of the cosmos, gravity and light are not separate threads. They are different manifestations of the same underlying phenomenon, woven together to create the universe as we know it.